We're going to now list numbers from a given set that are members of real number set, but before we get to that example, I would like to review the different types of numbers. The first numbers we have are called counting numbers. The actual name is natural numbers. If you remember when you were about 3 years old or 2 years old, you first started counting 1, 2, 3, and everybody started clapping. So those are our counting numbers. Our whole numbers add 0. That's why I have the 0 in red. The integers add the negative numbers. And then we have rational numbers. Rational numbers are considered any number that you could write with a denominator, numerator, and a denominator, but the denominator cannot be equal to 0. So those include the integers. Well, yes, you can take a whole number or an integer and make it a fraction by just saying, for example, 3 would be 3 over 1. So the rational numbers includes the integers, fractions, repeated decimals, and terminating decimals. For example, 0.25, which is 1/4, terminating. And then repeating 1/3, 0.333. So all of those are included with your rational numbers. Our irrational numbers is everything that we didn't talk about, such as pi, e, square root of 2, square root of 5. These numbers are non-repeating, and they are also non-terminating decimals. So if you look at pi, it would be 3.1416, blah, 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 but you never see a pattern. Once we know the rational numbers and the irrational numbers and put those together, it will be equal to the real numbers. Okay. So let's get to our example where we're going to look at the subsets and identify what type of numbers we have. If you get a set like this, the first thing you need to do is analyze it. And did you notice here a negative 16? That's 4. So they're trying. So they're trying to disguise a negative 16 as the square root of 16. I don't know why I keep saying negative. Square root of 16 is equal to 4. So let's look from the definitions that we've been given and come up with the answer. Our natural numbers, what did we say? They were our counting numbers, 1, 2, 3. So from this group that we have 3. We look over and also the square root of 16 because we said it was 4. The whole numbers would add 0 to that. So I have 0, 3, square root of 16. Now my integers will add the negative numbers. So I'm going to have the numbers that I already from the previous whole numbers, but I'm going to add my negative numbers, a negative 12. Okay. And I believe that's it. Now, rational numbers. We have to think closely. Let's go back and just take out the ones that we've chosen so far. Okay. Now, our rational numbers, we said, would have a numerator and a denominator. They could be terminating decimal or repeating decimal. So on rationals, we're going to include the same, but we're going to add, and I'd just like to change colors here. We're going to add 2/3 and 2.5. Okay. Let's take those out. So the only thing we have left now would be square root of 2. And if you put that in your calculator, you'll see that it does not repeat or terminate. So we'll have that. And if we combine the rationals and the irrationals, remember we get the real numbers. So that would be our entire set. You could write it over, or you could just say A. It's just 2.5. One thing to be mindful of, although we know square root of 16 is equal to 4, we have to continue to use square root of 16 in our list. Let's look at another example. First thing, what? We analyze. So what is a negative 12 over 3? That's a negative 4. And we have 2 to the third power, 8. Okay, so we want to now look at natural numbers. 8 is a natural number. It's a counting number. So that's the only one that we have. On the whole numbers, what did we do? We added 0. Now the integers are going to include the negative numbers along with what we already have. So I'm going to put a negative 12 over 3, not a negative 4. Okay, and I think that's it. Let's go to our rational numbers and let's go back and cross these out. Our rational numbers form of A over B, or they would also have terminating decimal and repeating decimal. So with this list, I'm going to include a negative 3.2. Okay, watch my penmanship. And 1.2, and that means that it repeats. So we're going to take that out and that out. So that means the irrational number is going to be just a square root of 5. And again, the real numbers would include everything in my set. So instead of listing those out, I'm just going to put B there.